Okay, so for our second example problem, we're going to build off the first problem, and we're going to consider just what this means for the energy economy of Ohio. Ohio still has a majority of its electricity generated by coal. Coal yields 30 gigajoules of electricity per metric ton. What we're going to ask here is, assuming that the coal plant is 30% efficient, how much coal is actually required to keep those light bulbs from question 1 lighted for the week? All right, so to tackle this problem, there's a couple ways we can go about this. But a couple things to remember. First of all, a gigajoule is 10 to the 9th joules, a billion joules. And a metric ton is 1,000 kilograms. All right, so if we take our LED situation, remember that we had 4,233,600 joules per week required to keep that bulb lit, or lighted is the proper way to say it. Okay, well, if we have coal yielding 30 gigajoules at 100% efficiency, how much coal do we need if it's actually 30% efficient conversion? There's 3 different ways you can set up this problem. They all give you the same answer. So I'll give you a couple. If we take that 4,233,600 joules per week, and we multiply by this factor of, for every 1,000 kilograms, okay, we're going to get 30 gigajoules. And if we remember, actually, at that point, we're only 30% efficient, so if we want to multiply that by 0.3, we would account for our efficiency right here. And then we can remember that 1 gigajoule is 10 to the 9th joules. Then we can see that we will end up canceling out our gigajoules, our joules, and we'll end up with kilograms per week of coal. Multiply that out, we get 0.4704 kilograms per week of coal. That's one way you can set this up. All right, the other way that I do, because I'm kind of a slow thinker, is I like to just think, well, first of all, if I just do the full conversion at 100%, then I can take and figure out what that efficiency factor is. So you could do the 4,233,000. So here's the first way to do this. The second way to do this. Joules per week times our 30 gigajoules per kilogram times our 1 gigajoule is 10 to the 9th joules. Well, at 100% efficiency, what that tells us is that we get .14112 kilograms per week. All right, so we end up seeing that at 100% efficiency, we would only have to burn 0.14112 kilograms of coal per week. However, we're not 100% efficient, so we have to say 30% of some larger value, x, equals this. Okay? To solve for x, we have to divide this by 30%, which is more or less the same thing as multiplying by about 3, and you end up with the same number of 0.4704 kilograms per week. And that's how I typically do it, but either way, you can see you're accounting for your efficiency term by dividing by the 30%. Okay, so, and then the only difference would be if you're comparing the energy with the incandescent, is you use the larger number to start with, and you're going to end up having to burn more coal. I won't bother to go through that arithmetic, the exact same ways you can do that. Okay, there's a third way you can figure it out yourself, but if that 30% you account for early on in the 30 gigajoules, if you multiply that by 0.3, then you end up with like a 0.009 gigajoules per week, and just multiply that through, and you should get the exact same answer. Okay?